Hi everybody, today's lesson is all about the transformer. So what is a transformer? What does it mean? So transform means to change. So what are we trying to change? So we're trying to change the voltage. And why is that needed? Now the thing is, you know that electricity power is generated in power stations and they are transmitted over long distances and they finally reach your homes. Now when power is generated using the generator, it's probably generated at some particular voltage and then it is transmitted over many kilometers through these power lines, and they are transmitted at low currents but with high voltage. And the reason why that's done is because otherwise a lot of energy would have gone as heat, because power is I squared R, so bigger the current, the more the energy that's lost as heat. So these high tension transmission lines over our heads actually carry very, very high voltages. Now what happens is when they reach the outskirts of the city, these voltages are actually brought down to a more usable and safe levels, and then they further step down so that you can get them in your power points. And in New Zealand we use about 240 volts for most of our appliances, and so we use transformers to step up or step down voltages. And transformers work on the principle of mutual inductance. So what is this transformer? So it actually ideally consists of two sets of coils. So one is called the primary coil and the other one is called the secondary coil. Okay, the primary coil is the one where there is an alternating current, so there is a constantly changing current and therefore changing flux, and that's going to induce a voltage around the second coil, which is called the secondary coil. Now what is the square thing I've drawn? That square thing I've drawn stands for an iron core. Why do we need an iron core? The thing is, iron is magnetic. So what the iron core does is that it increases the efficiency of a transformer so that it guides all the lines of flux from the primary to the secondary so that nothing is lost. So that's what the iron core does. Okay, so how do we know about what's the voltage in one and how does it compare to the other? Now there are certain things. So every time you make a coil, so each of these is called a turn when you wind a coil around something. So let's say the primary coil, the number of turns is NP, number of turns of the primary, and the number of turns of the secondary, we'll call that NS. Okay, these are actually related to the voltage across the primary divided by the voltage across the secondary. So this is the formula that links the voltage and the number of turns for the primary and secondary coil. Okay, so it's all proportional to each other. So more the number of turns, the bigger the voltage. So if the primary coil had a lot more turns compared to the secondary, then your voltage output of your secondary will be less, okay? So, and vice versa. If they're the same, the input voltage is going to be the same as the output voltage. Now, for an ideal transformer, there is no energy lost. You really don't have anything ideal. Always some energy is lost as heat. But if you look at ideal situations, then we say that the power input, whatever power you put in, is equal to the power output, because power has to do with the amount of energy spent each second, and power is voltage times current. So power input has to do with the voltage of the primary times the current through the primary is equal to the voltage across the secondary times the current across the secondary. Okay, so this is what happens for an ideal transformer. Power input equals power output. However, not all transformers are ideal. Some energy is lost as heat, and the way to calculate the efficiency of a transformer is equal to power input divided by, sorry, power output divided by power input times 100. Okay, because efficiency is always expressed as a percentage. So if you're getting less power out, then it's going to be less than 100. You'll never get more than you put in. Okay, so the maximum you could get is when the output is the same as input, and then you get 100% efficiency. Now, there are some ways that they increase the efficiency of transformers. So one of them is using an iron core. But if the iron core is a block of iron, then what happens is that the iron itself, when there's a changing current through that iron and changing flux, it generates the iron. There's current generated within the iron core itself. It sets up what are called eddy currents, little circular currents, and that results in heat being lost due to the resistance. So instead of having a block of iron, what they have is thin laminated sheets of iron. We do have demonstration transformers in school, so when you're back, I hope to show you some. So they're laminated sheets, so they're thin sheets which are separated from each other by a coating. So that's what we call laminated sheets all put together. And so that's one thing. So that's the second thing. So the iron core, laminated iron core. And the third thing they use is these wires are made of low resistance copper so that the current flows easily through them. Okay, so that is to do with the introduction to transformers. I'm going to do another short video about 3 different types of transformers. So I'll just pause this, otherwise it's going to become too long.